Hi dears, welcome to my channel. Today I am here with class 9, lesson number 7, that is motion. What was the sixth lesson, Kanna? We were in biology, right? Parenchyma, sclerenchyma, collenchyma, everything we have learned. In lesson number 6, that is tissues, there I have asked you 3 questions. It's the time to answer these questions. Are you ready, Kanna? Yes. First one was, which tissue has dead cells? Was the question. And the options were parenchyma, sclerenchyma, collenchyma, epithelial tissues. The correct answer is sclerenchyma. Okay. Second one is, cartilage is not found in dash. Cartilage is not found in which part? The options were nose, ears, kidney, larynx. The answer is kidney. Contractile protein is found in dash was the third question, and the options were blood, bone, muscle, cartilage. Contractile protein will be seen in muscles. Okay, I think you have answered the correct options and all of the things were correct for you. Now we are moving for entering in the world of physics. What is the first lesson, ma? It is motion. What is motion? Movement, right? That is motion. How can we define a motion? Before that, we should know what is rest. Then only we can say something is in motion, right? First, what is rest? We should know, na? We will say if you are keeping quiet, you are in rest. But we are comparing with some reference point. Then only we can say something is in rest. Okay? The body is said to be rest if its position does not change with a reference point. For example, when you are having a car and you have parked the car near a tree, and you can say that the car is at rest. When the car is not moving, is not changing its position with reference to the tree nearby, then we can say the car is in rest. Isn't it? Is it clear for you? Okay. When the car has been moved to a little extent, or it has been moved away, we can say that it is in motion, or it has been moving. Like that. So what is motion? The body is said to be in motion if its position is changing with reference point. Okay. We can say something not with reference point but with time also. When you have kept a book on your table, after half an hour the book has been there itself. So we can say that it is in rest with respect to time also. Half an hour before it was there only. Now also it is there only. So we can say the rest with compared to what, ma? With compared to time also. Okay. Now you understood the rest, and obviously it is clear for you about the motion. Body is said to be in motion when its position is changed with respect to reference point or with respect to time. Okay. Now we have to see some physical quantities. The quantities which can be measured are called physical quantities. Okay, and they will be having values. They are called what, ma? Physical quantities. We are comparing the physical quantities into two, that is scalar quantity and vector quantity. Scalar and vector. Okay, scalar quantities are the one which have only magnitude. For example, our scale. Can we see the scale? Okay. In the scale, what is that? Some numbers have been written. Yes or no? So numbers has been written, and we can say 1 centimeter, 5 centimeter is there, 20 centimeter is there. What is that? They are saying the value. When we have drawn with a pencil a distance 1 to 20, we can say I have drawn 20 centimeter. It is having only value. Okay? Or to say the time. Now it is 1 o'clock. Now it is 5 o'clock. Okay? They are saying about the value. 5 o'clock. It is 5. The time has become 5. The time is 1. Or the time is 12. There is having a magnitude. That means a value is there. Okay? To say our weight. I am 60 kilogram. I am 100 kilogram. I am 20 kilogram. All these are having a value only. Okay. Now I am going from my hometown to Bangalore. I am riding in a car 50 kilometers towards north. So it is having the magnitude 50 kilometer and towards north. Only then I will be able to reach Bangalore. Did you get ma? So it is having the quantities which is having magnitude as well as direction. These quantities are called vector quantities. Did you get ma? There is magnitude for them as well as some direction is also there. Okay. I am having a bat with me and the ball is coming in one direction. Okay. If I am kicking with my bat in opposite direction only, what will happen? The ball will be moving in some directions. So what I am doing? I am applying force. And the force is having direction also. Isn't it? If the ball is coming in one direction, I am moving in this direction, there will be one wicket will be gone out. Isn't it? For our cricket lovers. Huh? But when I am striking it in opposite direction, it will be moving, right? So direction is very essential for some quantities. So the quantities which are having magnitude, that means value, now numerical value as well as direction, in which direction it is moving, these quantities are called vector quantities, while the quantities which are having only magnitude, that is numerical value only, are called what ma? Scalar quantities. Now your turn, tell me what are some scalar quantities. As we know, our mass, scalar, isn't it? Time, scalar. Okay, to say speed, I'm moving the car speedily. Which direction? That I am not having any direction. It is all, and the distance, all are scalar quantities, while as I told you, the force. And we will learn what all things are vector quantities. We will learn, then only you will come to know what all things are vector quantities. We are going to learn all these. Okay, ma? The idea is clear for you about the scalar as well as vector quantity? Okay. Now, we are moving to see the distance. What is distance? I have gone to my school. Okay, I am going to my school. There are many ways to go to school. If I am going straight, I can reach. Okay, if I am going straight, within half an hour I will be able to reach. But what to do? I am having my favorite friend. I have to go and pick her up. I will go and pick her up. Then I will go to an ice cream shop with my pocket money for me and for her. We will buy ice cream and we'll eat. Then only we will go so late. So the direction will be changed, or I will be moving in some other way. But at the end I will reach school. Okay. In the first case, to say within 2 kilometers, I will be able to reach my school. Okay. In the second case, I am going to my friend's house and from there to an ice cream shop. Then I am moving to the school. It took 3.5 kilometers. Okay. So what is the distance in both the case? First case distance is 2 kilometers and in the second case the distance is 3.5 kilometers. Okay. So what is distance actually? Distance is the actual path length. Path length, how much, in which path we are going, and the actual path length is what ma? It is the distance. Okay. So there is some other thing, that is displacement. From the name itself it is clear. Displacement from one place to another place. From work to work, from home to school. It doesn't mean that you need not go with your friend and all. But what is the initial position? Home. What is the final position? School. So what is the displacement? Initial position and final position divided by initial position is the shortest distance from the initial position to the final position. Okay. Shortest distance. To which distance it can be reached quickly. Shortest distance is what ma? Displacement. It is a vector quantity while distance is a scalar quantity. Distance will never be negative. Distance will never be zero. Distance will be always positive. But the case of displacement, it can be positive, it can be negative, as well as it can be zero. The displacement is less than or equal to distance. When you are teaching me in this way, it is not easy for us to understand. You may be having such a feeling. I am here to explain to you. Okay. Seema, the child starts from this point. Is it clear for you? Can you see here? Starts from A and reaches to position B. Okay. Here, distance is A to B. And the displacement is also A to B. There is no other pathway. Straight it is moving from A to B. So, displacement is equal to distance in this case. Understood, ma? Displacement is equal to distance. There is a second thing. That is, a child starts from A and he is reaching his friend's home. Then he is moving to school. Okay. He is going to this way. Then he is going in this way. So what is distance? Distance is this plus this. AO plus OB is what, ma? Is the distance. But what is displacement over here? It is only AB. Initial position to the final position. This is what, ma? Displacement. Is it clear? Okay. Then a child is starting to say your mother told while you are watching your favorite cartoon. His mother is there now all the time calling. Called and said, go and buy some green chili for me. Okay? Green chili. So no other way going, right? So what will you do? You will take the bag and money also and you will go there, buy and will come quickly because our cartoon is moving. Right? So initial position is what, Magana? Home. Final position is what, Magana? Home only. So what is displacement? Initial position, home. Final position, home. Displacement is 0. Displacement is 0. So what is distance? Is it 0? No. You are going to shop. It is 200 meters away from my home. So 200 meter plus 200 meter, 400 meter is the distance, while displacement is 0. Is it clear? So displacement can be 0 also. Okay. You are in ground floor. You are coming to the basement where the car is parked. Your father has parked his car and you are in hotel for having your food. After having food, you are coming to basement to pick your car. What will be the displacement, Kana? Displacement will be negative over there. Direction is downwards. So displacement can be negative also. Displacement can be positive and the displacement can be 0 and displacement can be negative. Is it same for distance? No, never. Distance will be always positive. So displacement is less than or equal to distance. Is that point clear for you? Now we are moving to see speed and velocity. What is speed? Speed is the distance travelled by the body per unit time. That is, how much distance the body has been travelled per unit time. That means in respect to time, how much distance it is travelled. It is called what, ma? It is called speed. Okay? The car is having this much speed, we will say. It doesn't mean that the car is travelling towards north or towards south, towards east. We are not mentioning. Okay? This much speed is there. Okay? How much kilometer per hour it is. Because we are considering the distance with time. How much meter the car or the vehicle has been travelled or whatever it is, it has been travelled per second. The time is expressed there as a unit of time is second. So meter per second is its unit. So distance travelled by time makes the speed and it is always a scalar quantity because distance is a scalar quantity as well as time is also a scalar quantity. So speed is also what, ma? It is a scalar quantity. What is velocity? Velocity is the speed only, dears. But it will be having a direction also. Speed with direction makes the velocity. Is it interesting? Okay. The speed with direction is what, ma? Velocity. So we have to make a change. distance is the one which is not having what direction. But there is something which is having direction. What is that, ma? Displacement. Yes. So what is velocity? Displacement with time. How much the body is displaced with respect to time is what, ma? It is velocity. So is it a vector or a scalar quantity, Kanna? It is always a vector quantity, while speed is always a scalar quantity. What is average speed? Average speed is the total distance divided by time. Okay. What is average velocity? It is the initial velocity plus final velocity divided by 2. This is what, ma? Average velocity. You have to find the initial velocity, then you have to find the final velocity. That divided by 2 will give you what, ma? Average velocity, and it is always a vector quantity. So what do you understand by this vector quantity? It is having magnitude and direction is the first point, and second point is velocity can be positive, 0 and negative. But in the case of speed only, positive the value will be. Isn't it? All these things to be in your mind. What is the unit of velocity, Kanna? Same, meter per second. Because displacement can be equal to distance also, right? So how much it is measured? It is measured in meter, because SI unit of displacement as well as distance is meter, and time is SI unit is second. So meter per second is same for speed as well as for velocity. Is it clear, Kanna? Okay. Now we are moving for the next thing, that is uniform motion. The motion which is dressed in uniform is uniform motion. No. Uniform motion. What is uniform? Why uniform? That's the question for you. Why uniform is put for you when by the school? Everyone should be equal. There should not be a comparison that I am a rich boy, I am a rich girl, I am a poor girl, I am a poor boy. Like nothing like that. All are same. That's why uniform is put. So what is uniform motion? Is there any idea for you? Equal distance. Equal distance if the body is travelling in equal interval of time is called what, ma? Uniform motion. Motion is moving, isn't it, ma? There should be distance which has to travel, and the distance should be same in equal interval of time. So how the road should be for your movement? The road should be plain. Means linear motions can be, should not be, can be what? Uniform. Linear motions. Okay, we can say the time also. Time is circular motion, Kanna, but the time is also in a uniform motion. Isn't it? We can say time is in a uniform motion. And in a linear motions can be uniform based on the person. If he is putting brake and he is moving slowly, somewhere he is moving fastly, we can't say. But linear motion and circular motion in the case of time, all these, our clock, all these are what, ma? Example of uniform motion. What is non-uniform motion? Unequal distance travelled in equal interval of time. Time will be equal. Because I am taking 5 minutes, 10 minutes, 15 minutes, like that the time, 5 minute gap I am taking. But the speed is changing, varying. Non-linear motions are, and many, when the car is in traffic or your vehicle is in traffic, we can say always non-linear motion or non-uniform motion will be. When the traffic block will be gone, God only knows. Isn't it clear? So it is an example. Okay. We are moving to see what is acceleration. What is acceleration, Prana? God knows, sir. No, you know. Rate of change of velocity is acceleration. That is, when the velocity is getting changed with respect to time, it is called what, ma? Acceleration. Okay. When the velocity, you understood velocity, right? It is a vector or a scalar quantity, ma? It is a vector quantity. When this velocity is changing, when with respect to time, as the time is changed, the velocity is also changing, varying, only because it is moving in a non-uniform motion. If it is having a uniform motion, the acceleration will not be seen, because equal distance is covered in equal interval of time, there is no acceleration. That's why I told this uniform and non-uniform motion initially. Okay, but as the traffic is there, up to that extent the car is moving with uniform velocity, but when traffic block been come, everything has gone and it is stopped even. Okay, so what will happen within after sometimes the velocity will be changing, isn't it? Rate of change of velocity with time is called what, ma? Acceleration. As the velocity, uniform velocity has been changed to non-uniform, then only what happens? Acceleration will come. As I told you, it is a velocity is a vector quantity, acceleration is also a vector quantity which is having positive 0 as well as negative. Positive, I told you, it is not when a non-uniform motion it is there. And 0 also I told you. When velocity, if the body is moving in uniform motion, there will be acceleration 0. And negative acceleration is called what, ma? It is called retardation. Negative acceleration is also called what, ma? Retardation. Okay. When we can say the body is in retardation, if the initial velocity is greater than the final velocity. Initially I am moving in high speed, but finally the velocity has been gone. So when the velocity has been reduced, initial velocity when it is higher than the final velocity, the thing will be what, ma? It will be in retardation, negative acceleration. So what is the formula for acceleration, Kana? Always acceleration is final velocity minus initial velocity divided by time. Final velocity minus initial velocity divided by time is acceleration, and when final velocity is greater than initial velocity, acceleration is positive. When the final velocity is less than initial velocity, acceleration is negative. When the final velocity and the initial velocity are same, acceleration will be 0. Okay, is it clear about the acceleration? Okay. I told what is velocity? Unit meter per second. Did you remember? Do you remember, Kanna? Okay. Meter per second. As velocity is displacement divided by time, it is meter per second. So what is acceleration? Change in velocity by time. So meter per second divided by second. Isn't it, ma? Meter per second is velocity, Kanna, unit, and divided by second. So what will be acceleration? Meter per second square is the unit of acceleration. What is the unit of acceleration, ma? Meter per second square. Okay, the things should be in for your knowledge. Okay. Okay. Now I am saying some important symbols and some important units. Displacement as well as distance is having the symbol S. What is the symbol, ma? Displacement and distance. Don't say it as D because D is there now. Don't be over enthusiastic and write. The symbol is S, is for distance as well as displacement. Okay. Then initial velocity will be U, always represented as U. Final velocity will be always represented as V. Okay. Then acceleration will be always represented as small letter A. Okay, small letter A. These are the important terms which you should know. And the units also, it's easy for you, right? For speed, what is the unit? As well as for velocity, unit is meter per second. Isn't it, Kana? Where M is the unit of distance as well as displacement, and S is the unit for time. Isn't it, ma? Then acceleration, what is the unit, Kana? Meter per second square. Up to this extent, the things are clear, I think. Now we are moving for graphical representation. We are going to see the graphical representations of motion. Okay. Here in the first graph, I have written distance or displacement in y-axis while time in x-axis. Okay. As the time is moving, the distance is also moving. Okay. We are seeing whether the distance is moving uniformly or non-uniformly. Okay. When starts from initial 0 point, as the time is moving 1 second, it has reached this. When it has time has been changed to 2 seconds, it has reached this position. When the time is 3 seconds, this reached this position, and the time 4 seconds, it reached this position. So when we are joining, it will be like this. What, Kana? A straight line. isn't it? Going upward. So what we can say? We can say equal interval of time, the object is moving in equal distance. So what is it, ma? It's a uniform motion. Okay. So it is, we are seeing the velocity. Okay. The velocity here is uniform. We are understanding. Now there is something in second graph. Non-uniform motion we are going to see. Starts initially from 0. In 1 second it reached here. In 2 seconds it reached there. 3 seconds it reached here. 4 seconds it reached there. So when we are joining, it will be like this. What is this now? Is it moving in straight line? No. It is moving in curved path, which means what? The velocity is not uniform. It is moving in unequal distance, in equal interval of time. Okay. So we are said to be in non-uniform motion. Okay. Non-uniform motion here and uniform motion here. Okay. Yes. Now we are going to see velocity time graph. Here time always in x-axis and here velocity is in y-axis. Initially distance time graph it was, the distance was in y-axis and time was in x-axis. There we were able to find the velocity, because distance by time or displacement by time is what, ma? Velocity or speed. Distance by time is speed and displacement by time is velocity. Like that, it is easy to find the velocity. But here, this is velocity time graph. So what it will be able to be calculated? Velocity by time is what, ma? Acceleration, isn't it? So velocity time graph helps to find the acceleration. Okay. Let's start. 1, 2, 3, 4. Okay. Here starts from here, but it has been reached in 1 second here, 2 seconds here, 3 seconds here, 4 seconds here. So it will be a straight line. Here the velocity is not changing. Velocity is not changing, Kanna, because velocity is in y-axis and it is not changing, only in 2. Here I am written as 2 as it will be in 2 only. So velocity is not changing. So acceleration will be what, Kanna? It will be 0, isn't it? It will be 0. In this case, velocity and time, as we are changing 0, 1 second it has been reached here, 2 seconds here, 3 seconds here, 4 seconds here, will be a straight line. So what do you understand from it? Velocity is changing with time. Velocity is changing, Kanna, with respect to time. So acceleration is there or not? Acceleration is there because velocity is changing, so acceleration will come. When velocity is not changing, acceleration will never come, isn't it? Like that, if you are eating healthy food, disease will not come. If you are eating junk food, who will come, Kanna? Disease will come. Like that, right? Was it easy, interesting? Yes. Okay. When velocity changes, what happens? Acceleration comes. So what is the slope, Kanna? Slope is acceleration. Okay. Slope shows acceleration is there. Here slope shows there is no acceleration, no chance for disease, no chance for acceleration. Understood? Okay. So these are the graphs. I think it is easy for you to understand. Now we are moving to see the equations of motion. There are 3 main equations of motion. Okay. We have to understand what it is. First one is V is equal to U plus AT. Have to know it. V, final velocity is equal to initial velocity plus acceleration into time is the first equation. And the second equation, S is equal to, what is S here? S is what? Is it speed? I will kill you. S is distance or displacement. S is there, so speed it will be no. S is what, ma? It is displacement. In the case of vector quantity, in the case of here we will say only about the displacement mainly. So displacement is equal to what, Kanna? Ut plus half AT square. Should know. Ut plus half AT square is equal to what? S. And the third one is 2AS is equal to V square minus U square. 2AS is equal to V square minus U square. Why we should know all these? for understanding and also for getting good marks in numerics. Numerical problems will be there, right? For that you should understand, then only you will be able to answer these numerical questions. Okay. So what are the equations of motion? These three are the equations of motion. But they will ask in this way. Say the equation of velocity time relation. Who knows? God only knows. You should not say. Equation of velocity time relation is the first equation. Karna. Velocity time relation is V is equal to U plus AT. You should know in this manner also. What is its name? The name of equation of velocity time relation is the first equation. Karna. V is equal to U plus AT. Equation of position time relation. It is the second equation. Position. What is that? Position time relation. That is displacement is equal to ut plus half at square is the equation. And the third is equation of position velocity relation. Position velocity relation is 2as is equal to v square minus u square. In which form the question they will ask? We don't know. So we should know. We should understand this. Okay. Now the another question is coming. How we are able to find these are the equations and how we will be able to solve this? For that we should know how the equation is derived. How these equations are derived, you should know, right? For that I am here. Okay. From the slope of velocity time graph, we will be able to solve. Okay. Velocity time graph. See, Gana. Velocity time graph is there. Here, in a particular position, from initial velocity, it has been started. What is it started? The motion is started and moving to this direction and it has been stopped. In velocity time graph, if there is a straight line like this, what you should know? What should be blink in your brain? Acceleration is there because velocity is changing. So acceleration. What is slope, Kanna? Slope always shows what? Acceleration. So slope is acceleration. Slope is equal to acceleration, which is equal to rise by run. Like that we should run. Why? How it is raised and how it is normal. It is easy for you to understand. Rise. From this position it has been a rise, right? Divided by normal. Run. Gives you slope. Okay, ma? What is this rise? From this to this it has been raised. So AB is equal to this rise, Kanna, BD divided by AD. Clear? AB is equal to what? This triangle only we should know. AB is equal to BD divided by AD. Yes or no? Yes. What is this BD? BD is this is the initial position, Kanna, and this is the final position. So this starts from, this is U. This distance is U. And this total distance is V. What is V? V is the final velocity. Okay. So BD is equal to BC minus DC. Can you say? BD is equal to BC minus CD or DC. So what is BC? It is V. What is CD? It is U. So BC minus CD divided by AD, that is equal to V minus U divided by AD is, what is this? This is this. We are based on time T. So V minus U by T is equal to what? AD. What is AD? Slope. From that it is easy for you to understand. So V is equal to, it will go this way. Along with A, the T will go and the U will go that side. So V is equal to U plus AT. Such a relation will come for you. This is the derivation of equation. First equation has been derived. What is that? V is equal to U plus AT. What is this equation name? Equation of velocity time relation has been derived. Now we are going to see how the equation of position time graph relation came. Okay. Position time relation graph. What is the equation, Kanna? S is equal to ut plus half at square. How it came we are going to see. Okay, ma. Again this graph. is seen. Here, initial velocity is u, final velocity is v, and what is this one? This is acceleration. The slope is acceleration, and we have to find the area of the slope. In the first, we have seen just the slope, isn't it? Second one, we are seeing area of the slope. When we are finding the area of the slope, we will get displacement. What is the unit of how can we represent it as S? Okay. So area of the slope is, we can say OABC. This much part. This much part is what, ma? This is the area of the slope, isn't it, Kanna? So it includes two things. What are they? One, a rectangular part, and second is a triangular part. So area of this part is equal to sum of area of rectangle as well as area of a triangle. What is the area of rectangle? You have learned within 6th standard itself, right? 6th, no, 5th itself you will learn. What is the area of the rectangle, Kanna? Length into breadth, isn't it, ma? Okay, this is the rectangular part, Kanna. So what is the length over here? We can say OC into OA. Okay? OC into OA. Okay, this will be the length. Okay, so OC is what, ma? This is time. As it is moving, this is the time, Kanna. This is time into OA is what, ma? Initial velocity u. So OC into OA will become u into t. Okay, rectangular part is over. Then what is the area of the triangle? Half BH, half into base into height, isn't it, ma? Half BH. This is the triangle. Which part, ma? This part is the triangular part. Base is what, ma? AD. Okay, this is equal to OC, so it will become T. And what is H? H is this only. BD is H. In the first equation, we found BD as BC minus DC, isn't it, ma? Because BC is V, final velocity, minus DC, it is equivalent to OA, it is the initial velocity. So V minus U will become what, ma? B minus U become BC. BD is equal to BC minus CD, that's equal to V minus U. When we are applying UT plus half T into V minus U will be getting. But what is V minus U? In the equation we have seen V is equal to U plus AT. So V minus U is equal to AT. We are substituting, instead of V minus U, we are substituting AT. So what will be that? UT plus half T into AT. That is S is equal to UT plus half AT square. Don't feel that it is so difficult. It is very easy. If you are understanding, it will be very easy. We don't know whether it will be coming for your exams. But if you are understanding, the things will be much more easy to remember. Okay, ma'am? Okay. Thus, we got equation of position time relation. What is that, ma'am? S is equal to UT plus half AT square. Then we have to find the equation of position velocity relation. Position velocity relation. Then also we are finding what? Area of the slope. When we are finding the area of the slope, what will be that? It is equal to displacement. We are representing it as S. S is equal to, how did we we calculated initially? We were adding area of triangle and area of rectangle in the position time relation. But here we are considering it as a trapezium. What is this trapezium, Kanna? You have already learned. What is the specialty of trapezium, Kanna? One of the opposite sides are parallel while other opposite sides are not parallel, isn't it? Two sides, one side, Kanna, here, this is parallel to this. But this is not parallel to this, isn't it? So one of the opposite sides are parallel while the other opposite side is not parallel in the case of trapezium. So what is the area of trapezium? While we are finding the area of trapezium, it's easy to find out the equation. What is the area of trapezium? Quick! Come on, quick! Area of trapezium is half into parallel sides into height. What is that, ma? Half into sum of the parallel sides into height. Okay. What are the parallel sides, Kanna? This side and this side. it is easy, Karna. This is u and this is v. Half into v plus u or u plus v into what is the height over here? For that, we are turning the trapezium in this manner. This is u. This is v. This is what, ma? Height. What is height? Now tell me what is height. It is equal to t, isn't it? Half into u plus v into t. Okay? Okay. Here, if we are writing in this manner, we will not be able to find the equation fully. For that, we are changing the value of t. How can we write t in other way? We have already learned v is equal to u plus a, the first equation. From that, we are deriving t. What is t, ma? T is v minus u divided by a. Yes or no? Yes. V minus u divided by a is equal to what? It is t. So, we are substituting this value or this instead of t. So, when we are substituting, u plus v into u minus v will come. What is the other form of a plus b into a minus b? A plus b into a minus b is equal to what? A square minus b square. You have learned it, right? So, v plus u into v minus u will become what? V square minus u square. So, v square minus u square will be 2as. What is s? S is the displacement. S is equal to all this, right? So, S is equal to 2as is equal to v square minus u square. In that manner, we will get. This is the third equation. Isn't it? What is the equation? Equation of position velocity graph. Did you get it? This is the way how we are getting only one graph. From this, we are finding the three equations we are deriving. Okay, ma'am? Now, we have to have a small part. That is, in circular motion, what will be the speed? If the object is moving in a circular motion, what will be the speed? It is the circumference. What is the distance over here, Kanna? Distance will be what? Distance will be circumference of the circle. What is the circumference of the circle? 2 pi r. Do you remember? Yes. Circumference of the circle is 2 pi r. 2 pi r, that is distance, divided by time. Speed is what, ma? Distance divided by time, right? So, the speed for the objects which are moving in circular motion is what, ma? 2 pi r divided by t. These all equations are very essential for answering the numerical questions, which will be following in next video. Okay, dears? Now, I think the things are clear for you. If you are having any doubt, you can comment in comment box something I didn't understand, or can you make it clear? I will do from my part I will do my help. Okay, dears? Now we are moving for the question time. Are you ready? Questions are here for you. First question is, a particle is moving in circular path with radius r. Displacement after half a circle is dash. A particle is moving in circular path, Kanna. After half a circle, what will be the displacement? Displacement. Okay? Second one is, slope of velocity time graph is dash. Very easy, right? Slope of, no, I should not see. Slope of velocity time graph. That slope is showing what? Very easy. Okay. Third one, area under velocity time graph represents a physical quantity unit. What is the unit? Area is representing a physical quantity, right? What is the unit of it? Is the question. Okay. I think the questions are clear for you. We can meet in the next class. Bye.